Hello friends, now we'll start the new chapter Pythagoras Theorem. In this chapter, that is the first part that we will learn, that is the similarities of the right angle triangle, then the geometric mean theorem, and using that the similarity of the right angle triangle, we will prove the Pythagoras theorem. Let us start now. Pythagoras theorem. Let's recall. In previous standard, we have learned this, the Pythagoras theorem, formula for the Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equal to sum of the squares of remaining two sides. Now see this here. In triangle PQR, here is a PR square is equals to PQ square plus QR square. That is in right angle triangle. The square of the hypotenuse, here hypotenuse is a PR, is equals to the sum of the squares of the remaining two sides. That is a PQ square plus QR square. In triangle PQR, measure of angle PQR is 90, and therefore we can write that is the length of PR square is equals to length of PQ square plus length of QR square. And that's why we will have, that is a, we will write this as PR square is equals to PQ square plus QR square. This is the first. Again, we will recall this in right angle triangle. I am showing what is I had written on the board. The square of the hypotenuse is equals to the sum of the squares of the remaining two sides. In triangle PQR, that is the measure of angle PQR is equals to 90. Length of PR square is equals to length of PQ square plus length of QR square. And we'll write here as this is as PR square is equals to PQ square plus QR square. Now the next is Pythagorean triplet. In a triplet of natural numbers, if the square of the largest number is equal to sum of the squares of the remaining two numbers, then the triplet is called Pythagorean triplet. What is that? The largest number is equals to the sum of the squares of the remaining two sides, then that triplet is called the Pythagorean triplet. For example, 11, 60, 61. Here is 11 square is a 121, 60 square is a 3600, and 61 square is 3721. And therefore 121 plus 3600 is equals to 3721. Therefore the 11, 60, 61 is a Pythagorean triplet. For more information, again you can see this here. The Pythagorean triplets means what is I written on the board. Here is that in a triplet of natural numbers, if the square of the largest number is equals to the sum of the squares of remaining two numbers, then the triplet is called the Pythagorean triplet. For example, 11, 60, 61. 11 square is a 121, 60 square is a 3600, 61 square is a 3721. Therefore, 121 plus 3600, that is equals to 3721. And that's why 11, 60, 61 is a Pythagorean triplet. Okay. Now the next is for more information, if A, B, C are natural numbers, now this is very interesting, and A is greater than B, then A square plus B square, A square minus B square, and 2AB is a Pythagorean triplet. Now see this here. If we take, that is A is equals to 4, B is equals to 3, then A square plus B square, that is 4 square plus 3 square, 16 plus 9, that is a 25. See this here. A square minus B square, 16 minus 9, that is equals to 7. 2AB, that is a 2 into 4 into 3, that is a 24. Therefore, 7, 24, 25 is a Pythagorean triplet. This is the Pythagorean triplet. Now see this again here. This is for more information. You can construct the Pythagorean triplets by using this formula. For this, one condition is that here A is greater than B, A square plus B square, A square minus B square, 2AB is a Pythagorean triplet. For example, if we take A is equals to 4, B is equals to 3, then A square plus B square, that is the 4 square plus 3 square, 16 plus 9, that is A square plus B square, that is equals to 25, A square minus B square, 16 minus 9, that is equals to 7, 2AB, 2 into 4 into 3, that is equals to 24. Therefore, the 7, 24, 25 is a Pythagorean triplet. Now, let us start the next. Again, we also learn this property in the 9th standard. What is that property? The property of 30, 60, 90 degree. That is, if acute angles of right angle triangle are 30 degree and 60 degree, then the side opposite to 30 degree angle is half of the hypotenuse, and the side opposite to 60 degree angle is root 3 upon 2 times the hypotenuse. Now, see this in this figure. This is triangle ABC. Measure of angle B is equals to 90. Measure of angle A is equals to 30. C is 60. Therefore, BC is equals to 1 upon 2 AC. BC is equals to 1 upon 2 AC. And AB is equals to root 3 upon 2 AC. This is the property, that is the when in a right angle triangle, the side opposite to angle 30 is half of the hypotenuse and side opposite to angle 60 is root 3 by 2 times the hypotenuse. Again, see this here. The property of 30, 60, 90 degree. If the acute angles of right angle triangle are 30 degree and the 60 degree, then the side opposite to 30 angle is half of the hypotenuse and the side opposite to 60 is root 3 upon 2 times the hypotenuse. Now see this in this figure. In triangle ABC, measure of angle B is 90, A is 30 degree and C is 60 degree. Now here BC is equals to 1 upon 2 AC, which is the hypotenuse, and AB is equals to root 3 upon 2 AC. Now we'll learn next property, that is the property of 45, 45, 90 degree. Again very interesting. This property we have learned in the 9th standard. 45, 45, 90 degree. If the acute angles of right angle triangle are 45 degree and 45 degree, then each of perpendicular sides is 1 upon root 2 times 1 upon root 2 times the hypotenuse see this here. This is triangle PQR. P is 45, R is 45, PQ is equals to QR is equals to 1 upon root 2 PR. PQ is equals to PR. Now this is a right angle also isosceles triangle. These two sides are equal. Therefore PQ is equals to QR is equals to 1 upon root 2 PR. Now see this again here. The property of 45, 45, 90 degree, here is a 0. Let's I forget to write here. Let's write here. We have the 0 here. This is 90 degree. If the acute angles of right angle triangles are 45, 45, then each of the perpendicular side is 1 upon root 2 times the hypotenuse. That is PQ is equals to QR is equals to 1 upon root 2 PR. Now we'll see the next, and which is the new topics. This we have learned in the 9th standard. Now this is important. Similarity and right angle triangle. By using this, we will prove the Pythagoras theorem. Theorem. In a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are is drawn to the hypotenuse. Then two triangles formed are similar to the original triangle and 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 to each other. Now see this here. This is a right angle triangle ABC. B is 90 degree and BD is a perpendicular to AC. Now in this case, this is very important. I had made the sign for the angle A. This is a small cross is here. Measure of angle, as BD is a perpendicular to AC, therefore the measure of angle ADB is a 90 degree. And I had given one more sign, that is here is a small circle is here for this. And again, for the triangle, that is a BDC, there is a small circle. I have taken here the cross, 90 and the circle. Again, one thing is that the cross and the small circle, the sum total is 90 degree. Because measure of this angle is 90 degree, cross and this is the small circle. Now see this, the sign, what is the sequence of this sign? That is, first is cross, 90 and the small circle. When we come here, then this becomes the cross, which is the angle, that is a DBC. BCD is the small circle. Now the next is, now in this case we have total 3 triangles are here. That is, the first is A, D, B. The next is B, D, C, and big one, which is the original triangle, which is A, B, C. I have taken one sequence. What is that sequence? The sequence is cross, 90 and the circle. This is my sequence. Now let us see. Given in triangle ABC, measure of angle ABC is 90 degree, no problem. Segment BD is a perpendicular to segment AC, A dash D dash C. This is given. Now to prove, triangle ADB is a similar to triangle ABC. BDC is a similar to triangle ABC. This is important. This sequence is important. Always that in what sequence we should take the triangles. I had taken the sequence is that ADB, ADB, that is, this is a cross, 90 and the circle. ABC cross, B is 90 and the circle. This is sequence. Also BDC, that is a cross, 90 and the circle, and ABC. This is my sequence. Now see this here. That is a triangle ADB is similar to triangle BDC. It means that these two triangles are similar, which is that ADB is similar to BDC. Now we will prove this here. I had written my sequences here, cross, 90 and the small circle. In triangle ADB and triangle ABC, angle DAB is congruent to BAC, which is the common angle. See this here. What is here? DAB, BAC. Angle A is a common here. What about the next angle? Next angle is ADB, 90, ABC. This is the 90. And hence, ADB is congruent to BAC, each 90. One thing is that here is a ABC. By mistake, I had written there is a, I had changed there. This is the ABC. That is a ADB is a congruent to ABC. Now, next is, therefore, triangle ADB is a congruent to This is similar sign, that is a triangle ADB is a similar to triangle ABC by the angle test. Now the next is, by mistake I had written it is a congruent, but it is not congruent. They are the similar. I had changed it. Now the next is by the angle test. Use this is a similar. This is only the similar sign. By mistake I had written there. Now next, BDC and ABC. Again, C angle is common to both of them. This is C angle. And BDC is a congruent to ABC, each 90. Therefore, these two triangles are similar. BDC is similar to ABC. This I had corrected here by the angle test. This is number 2. Therefore, from 1 and 2, that is the ADB is similar to BDC. This is third one. And hence, from 1 to 3, triangle ADB is similar to triangle BDC, similar to triangle ABC by the transitivity. This is the similarity of the right angle triangle. Now see this again here. Similarity and the right angle triangle. I will show whatever that I had written on the board. Theorem. In a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. Now, in this triangle, that is a triangle ABC, measure of angle B is 90, BD is a perpendicular to AC. Then we get the triangle ADB, BDC. These two triangles are similar to each other. They are also similar to the original triangle. And A dash D dash C, that is the point D is in between A and C. Therefore, the triangle ADB is similar to triangle ABC. Triangle BDC is similar to triangle ABC. Triangle ADB is similar to triangle BDC. Now we will prove here. I had taken the sequence I had written for my sake of convenience to remember. What is my sequence? That is, this is a cross, 90 and the circle. Cross 90. Therefore, the triangle ADB and the ABC. Whatever that, here is the angle A is a common, and the angle DAB is a congruent to angle DAC, which is a common. Angle ADB, ADB and the ADC, which is the 90, and therefore these two triangles ADB is similar to triangle ABC by the angle test. Now the next is a BDC and ABC. Therefore, ABC total and BDC. See, angle C is a common. Here is a angle BCD is a congruent to ACB, which is the common. ACB, ACB, and BCD, which is the common. Next angle, that is a BDC. This is the BDC and ABC, each 90. Therefore, these two triangles are similar by the angle test. And therefore, as from 1 and 2, that is the ADB is similar to triangle BDC from 1 and 2. That's why we are getting the third one. And from 1 to 3, that is a triangle ADB is similar to triangle BDC is similar to triangle ABC. That is by the property of the transitivity. Now see this again here. Now the next is theorem of geometric mean. In right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segment into which the hypotenuse is divided. See this here. This is the figure. The right angle triangle PQR. QS is a perpendicular to PR. This is the geometric mean. That is SQ square is equals to PS into SR. This is we want to prove. Now see this in this figure. In right angle triangle PQR, segment QS is a perpendicular to hypotenuse PR. Now this is the measure of angle R is denoted by the small circle. Here is a cross and the 90. And again here is a cross, small circle and the 90. These are the small signs so that we do not make the mistake in writing the 1 corresponding. Now see this here. That is a triangle QSR and the triangle PSQ. These two triangles are similar to each other. Therefore, QS upon PS is equals to SR upon SQ. And if you make the cross multiplication, that is QS upon PS is equals to SR upon QS. Therefore, the QS square is equals to PS into SR. Therefore, the segment QS is the geometric mean of segment PS and SR. Now we'll prove this here. See this from the figure. In a right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segment into which the hypotenuse is divided. Now in this case, the triangle PQR, measure of angle Q is 90, R is small circle, here is a cross and small circle. QS is a perpendicular on the hypotenuse. Therefore, we get these two small triangles. They are the similar to each other, and I am writing the name of these two small triangles in this sequence. That is a cross. This is a 90 and the circle. The first is that is a QSR, cross 90 circle QSR. What about the second? PSQ. This is, as these two triangles are similar, therefore their corresponding sides are in proportion. Therefore, I will take that is a QS upon PS. What I want to prove that? I want to prove that that is a QS is a square is QS square is equals to PS into SR. Therefore, QS upon PS is equals to SR upon SQ. Therefore, QS upon PS is equals to SR upon SQ. Therefore, QS square is equals to PS into SR. And therefore, QS is the geometric mean of segment PS and SR. Now, we'll see now the next Pythagoras theorem. Pythagoras theorem. In a right angle triangle, the square of hypotenuse is equals to the square of the hypotenuse is equals to the squares of the remaining two sides. Now in this figure, the square of the hypotenuse, that is AC square, is equals to AB square plus BC square. Now in triangle ABC, angle ABC is equals to 90 degree. To prove AC square is equals to AB square plus BC square, construction, draw perpendicular segment BD on side AC, A dash D dash C. Proof. In the right angle triangle ABC, segment BD is a perpendicular to hypotenuse AC. This is the construction. We get the two triangles. That is a triangle ABC. Now these are the sign, again the small circle 90 degree and the cross. Here is a small circle 90 degree and the cross. See this here. This is sequence, circle 90 degree and the cross. Now in this sequence we will take the triangles. Therefore we get, it's a very simple. Now see this here. The triangle ABC is similar to triangle ADB, is similar to triangle BDC. That is the similarity of the right angle triangle. What's my sequence? My sequence is a small circle 90 degree and cross. Small circle 90 degree and the cross. That is a BDC. This is BDC. Next is a ADB, and main triangle is a, that is original triangle is a ABC. These are the similar. Now what main thing is in the Pythagoras theorem? That is, first we equate this is the original triangle and small triangle. These are the similar, their corresponding sides are in proportion. From this we will find out the value of AB square. The value of AB square. And next is a triangle ABC and the BDC. We will find out the value of BC square. Add these two. Then we will get, there is a AC square, that is AB square plus BC square is equals to AC square. Now see this here. 1, 2, 3. Now ABC is a similar to triangle ADB. AB upon AD, BC upon DB, AC upon AB. Now see this here. AB first two upon these first two. BC second and third DB. AC, this is AC upon AB. Therefore the corresponding sides AB upon AD will take here. For these two triangle, side AB is a common. Then which ratio we will take here? AB upon AD is equals to, where is AB again? Here is AB. AC upon AB. Therefore we will make here cross multiplication. Then you will get AB square is equals to AC into AD. AB square is equals to AC into AD. This is equation number 1. Similarly, first and, that is ABC and the BDC. Which side is common? BC side is common. Now again here we will write their corresponding sides are in proportion. AB upon BD is equals to BC upon DC is equals to AC upon BC. Now here, where is the BC? To which ratio there is BC? For this ratio and these ratios, BC cross multiplication. BC square is equals to AC into DC. Corresponding sides. Therefore, BC upon DC is equals to AC upon BC. Therefore, BC square is equals to AC into DC. This is number 2. Now we add these two equations, equation 1 and equation 2. AB square plus BC square is equals to AC into AD plus AC into DC, which is common. AC is common. Then what is in bracket? AD plus DC. But what is AD plus DC? AD plus DC is nothing but again the AC, and AC into AC is AC square. Therefore, you will get AC square. Therefore, AB square plus BC square is equals to AC square, and hence it's approved. Now see this again here. I will repeat again here from the board. That is Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equals to the squares of the remaining two sides. In triangle ABC, that is the measure of angle ABC is equals to 90. To prove that AC square is equals to AB square plus BC square, draw the perpendicular on the side AC. In a right angle triangle ABC, BD is a perpendicular to the hypotenuse AC. ABC is a similar to ADB is a similar to BDC. That is the similarity of the right angle triangle. My sequence is like this: small circle, 90 degree and the cross, small circle, 90 degree and the cross. In this sequence, you can take the name of that triangle, then you will get the correct answer. Therefore, now first and second, these are similar. Now write their corresponding sides and in proportion AB upon AD, BC, here DB, AC, AB. Where is AB? Which is AB side is a common for this small and the original triangle. Therefore, we will find out first of all AB, that is first and last. Make the cross multiplication, you will get AB square is equals to AC into AD. Similarly, ABC and the BDC, ABC and BDC. BC is common, therefore we will write their corresponding sides. AB upon BD is equals to BC upon DC is equals to AC upon BC. Make their cross multiplication. Where is a BC? Here is a BC upon DC is equals to AC upon BC. And therefore BC square is equals to AC into DC. Add this to equation. AB square plus BC square is equals to what you are getting, AC into AD plus AC into DC. Take AC as a common. AD plus DC, which is AC, AC into AC, AC square, and hence the Pythagoras theorem is approved. And the measure of angle in a triangle ABC, when a measure of angle B is 90, then AB square plus BC square is equals to AC square. Now we prove the converse of Pythagoras theorem. Now see this here. What's happening in the converse? That is in a triangle, if the square of one side is equals to the sum of the squares of remaining two sides, then the side opposite to, then the triangle is a right angle triangle. No problem. That is given in triangle ABC. AC square is equals to AB square plus BC square. This we have given. Now we want to prove that measure of angle ABC is 90 degree. And here for that we will construct the triangle, that is a PQR. ABC is a triangle and another triangle is a PQR. Measure of angle Q is equals to 90 degree. Measure of angle Q is 90 degree here. I forget to write here, but Q is 90. Draw the triangle PQR such that AB is equals to PQ, BC is equals to QR, PQR is equals to 90 degree. Therefore, in triangle PQR, measure of angle Q is 90. Therefore, by the Pythagoras theorem, PR square is equals to PQ square plus QR square. But we know that PQ is equals to AB, QR is BC. Therefore, we will replace here. PQ means what? AB square. This is the AC square. That is, in that here is a, this is the BC square. I am changing it. This is nothing but the AC square. Therefore, PR is equals to AC. It means that all the three sides of the triangles are congruent. Therefore, triangle ABC is a congruent to triangle PQR by the S.S.C test. But the measure of angle Q is 90. Therefore, measure of angle B is also 90. And hence, the converse of the Pythagoras theorem is approved. Now see this again. I will show what is I had written on the board. The converse of the Pythagoras theorem. In a triangle, if the square of one side is equals to the sum of the squares of the remaining two sides, then the triangle is a right angle triangle. Given in triangle ABC, AC square is equals to AB square plus BC square. To prove that angle ABC is 90, in triangle ABC, what's happening? AC square is equals to AB square plus BC square. Now one thing is that I forget to write here. This is the measure of angle. This Q is a 90. I will change correct here. Measure of angle is 90 degree. Now see this here. Now what is my construction? Draw the triangle PQR such that this PQ is equals to AB and this QR is equals to BC. Therefore, we will draw this triangle. Measure of angle Q is 90. Now in triangle PQR, measure of angle Q is 90. Then by Pythagoras, what we will have? That's a PR square is equals to PQ square plus QR square. That's what we write it. But what is the PQ? PQ means AB square. What is the QR? Means BC square. AB square plus BC square is equals to AC square. Therefore, PR square is equals to AC square. Therefore, PR is equals to AC. And therefore, that is all three sides of this ABC is congruent to the three sides of PQR. And therefore, these two triangles are congruent by S.S.C test. As these two triangles are congruent, their corresponding sides and angles are congruent. But measure of angle Q is 90 degree. Therefore, measure of angle B is also 90 degree. And hence, it is approved. Measure of angle ABC is equals to measure of angle PQR, that is equals to 90 degree. This is the CACT, corresponding angles of congruent triangles. And in this way, we have proved the converse of Pythagoras theorem. Practice set 2.1. Now the first example. Identify with reason which of the following are Pythagorean triplets. The first is 3, 5, 4. In all examples, we'll write that is a C is a greater number. C is equals to 5, A is equals to 3, B is equals to 4. Therefore, C square is equals to A square plus B square. For that, 5 square is equals to 3 square plus 4 square. That is a 9 plus 16. Both are equal. And hence, the square of largest number is equals to the sum of squares of the two other two numbers. 354 is a Pythagorean triplet. Now see this again here. Practice set 2.1, where this is the Pythagorean, that is we know this, that is a C is 5, A is 3, B is 4. C square is equals to A square plus B square. These are the small numbers, therefore we can write directly. That is 5 square is equals to 3 square plus 4 square. This is equal. Therefore the square of the largest number is equals to the sum of the squares of the other two. Therefore 354 is a Pythagorean triplet. Now next is second one. 4, 9, 12. C is a 12. Always we are taking C is a greater number. A is a 4. B is 9. A square, C square is a 144. A square is 16. B square is 81. C square is equals to 144. A square plus B square, that is 16 plus 81, which is 97. Therefore C square is not equals to 144 is not equals to 97. Therefore C square is not equals to A square into B square. Therefore C square is not equals to A square plus B square. And therefore the square of the largest number is not equal to the sum of the squares of other two numbers. Therefore 4, 9, 12 is not a Pythagorean triplet. Next example, 5, 12, 13. Here C is equals to 13, A is equals to 5, B is equals to 12. The square of C square is 13 square, that is a 169. A square is equals to 25, B square is equals to 144. Therefore 169 is equals to 25 plus 144. Therefore 169 is equals to 169, and hence C square, that 13 square, is equals to 5 square plus 12 square, and therefore the square of largest number is equal to the sum of squares of other two numbers. Now next is, these are the simple questions. 24, 70, 74. C is equals to 74, A is equals to 24, B is 70. C square, that is a 74 square, which is the 5476. A square is a 24 square, that is a 576. B square is equals to 4900. A square plus B square, that is 576 plus 4900, that is A square plus B square, which is equals to 5476. That is C square is equals to A square plus B square. Therefore the square of the largest number is equals to the sum of the squares of other two numbers. Therefore, 24, 70, 74 is a Pythagorean triplet. Now the next is fifth one, 10, 24, 27. Now here C is equals to 27. Next is A is equals to 10, B is equals to 24. C square, that is a 27 square, which is equals to 729. A square is equals to 100. B square is equals to 576. C square is equals to 729. A square plus B square is equals to 100 plus 576, which is equals to 676. Now these two are not equal. 729 is not equals to 676. Therefore, 27 square is not equals to 10 square plus 24 square. Therefore, the square of the largest number is not equals to the sum of squares of other two numbers. Therefore, 10, 24 and 27 is not a Pythagorean triplet. Now the next example is 11, 60, 61. C is a 61. We always take C as a biggest number. A is equals to 11. B is 60. C square is equals to 61 square, 3720. A square is 121. B square is 3600. C square is equals to 3721. A square plus B square is equals to 121 plus 3600, and which is equals to 3721. It means that 3721 is equals to 3721. 61 square is equals to 11 square plus 60 square. Therefore, the square of the largest number is equal to the sum of the squares of other two numbers. Therefore, 11, 60 and 61 is a Pythagorean triplet. Now the next is question number 2. In figure, angle MNP is equals to 90 degree. Segment NQ is a perpendicular to MP. MQ is equals to 9. QP is equals to 4. Find NQ. See this here. This is the figure. Now see this figure. That is in triangle MNP. NQ is a perpendicular to MQ. MQ is 9. QP is 4. Find the value of NQ by the geometric mean. MNP. Segment NQ is a perpendicular to segment NP. Therefore, also angle N is a 90 degree. Therefore, by theorem of geometric mean, NQ square is equals to MQ into PQ. NQ square is equals to 9 into 4, that is equals to 36. Therefore, NQ is equals to 6. This is the value of NQ. Now see this again. If you want to see from here. This is the triangle MNP. NQ is the perpendicular. By the theorem of the geometric mean, NQ square is equals to MQ into PQ. That is 9 into 4, 36. NQ is equals to 6. Very simple one. Next is problem number 3. In figure, angle QPR is equals to 90 degree. Segment PM is a perpendicular to QR and QM dash R. PM is equals to 10, QM is equals to 8. Find QR. Now see this the triangle. This is the triangle PQR. PM is a 10. QM is 8. Find the value of QR. First of all, this is right angle triangle. P is a 90 degree measure of angle QPR. Now this is perpendicular. Again by the theorem of the geometric mean, PM square is equals to QM into MR. Now see this again here. QPR is equals to 90 degree. Segment PM is a perpendicular to segment QR. By the theorem of geometric mean, PM square is equals to QM into MR. 10 square is equals to 8 into MR, 100 upon 8. Therefore, MR is equals to 12.5. QR is equals to QM plus MR. 8 plus 12.5, that is equals to 20.5. Therefore, QR is equals to 20.5. Now see this again here from the board. This is in figure. That is an angle QPR is equals to 90. Segment PM is a perpendicular to segment QR. QMR, that M is in between Q and R. PM is 10. QM is 8. Then find the QR. Therefore, now see this figure. In triangle PQR, measure of angle QPR is equals to 90 degree. Segment PM is a perpendicular to QR. Then by theorem of the geometric mean, PM square is equals to QM into MR. 10 square is equals to 8 into MR. 100 upon 8, that is equals to MR. Therefore, MR is equals to 12.5. Now, what is a QR? QR is equals to QM plus MR. And that is equals to 8 plus 12.5, which is equals to 20.5. Therefore, QR is equals to 20.5. Now, see this next example. See the figure. RP and PS. Find RP and PS using the information given in triangle PSR. So this is the triangle PSR. PSR. The measure of angle S is 90, 30 degree P is. And one thing is given that as this is the 30, 90. The measure of angle is 60 degree. Now side opposite to angle 30 is 6. Therefore the hypotenuse 2 times. This is the 12. What about the PS or the SP? Is root 3 by 2 into hypotenuse, that is equals to into 12. That is root 3 by 2 into 12. That is a 6 root 3. Now this is very simple question. In triangle PSR, angle P is equals to 30 degree, angle S is equals to 90 degree, angle R is equals to 60 degree, SR is equals to 1 upon 2 PR, measure of angle. These are the 30, 60, 90 degree. 6 is equals to 1 upon 2 PR, PR is equals to 12. Also, SP is equals to root 3 upon 2 PR, that is a side opposite to 60 degree. Therefore, SP is equals to 6 root 3. Now, we will see this again here. This is, see the figure. Find PR and the PS using the information given here. That is, measure of angle P is a 30. This is the 90 and the 60. SR is equals to 1 upon 2 PR. Therefore, 6 is equals to, as the side opposite to angle 30 is half of the hypotenuse. Therefore, PR is 12. SP, that is side opposite to angle 60. This is measure of angles, which is root 3 upon 2 PR. Therefore, SP is equals to 6 root 3, and we have these two values. Now, the next problem. For finding AB and BC with the help of the information given in the figure, complete following activity. Now this is triangle ABC. Measure of angle B is 90 degree. AB and BC are the same, and the hypotenuse is root 8. AB is equals to BC is equals to both are equal. Measure of angle BAC is equals to question mark. AB is equals to AC. AB is equals to BC is equals to, this is the fill in the blanks that we have to put here. Correct answer into AC. Again, the value of AC, that is root of 8, and root of 8 is nothing but 4 into 2. Now see these here answers. AB is equals to BC, this is given. BAC, that is equals to 45. Next is AB is equals to BC is equals to 1 upon root 2 AC. Next is 1 upon root 2 into 8, root 8. And next is 1 upon root 2 into 2 root 2. That is root 2 get cancelled. You will get the answer 2. Therefore, again, see this here. For finding the AB and the BC with the help of the information given in the figure, complete the following activity. AB is equals to BC. This is the given. BAC is a 45. AB is equals to BC is equals to 1 upon root 2 AC. 1 upon root 2 into root of 8. The root of 8 is a 4 into 2. The square root of 4 is 2. 2 root 2. Now here root 2 get cancelled, and we have the AB is equals to BC is equals to 2. Now the next problem. Number 6. Find side and the perimeter of a square whose diagonal is 10 centimeter let x be the side of square. See this figure. So the square, each angle is 90 degree. 10 centimeter is a diagonal and these are the sides. Therefore, by using the Pythagoras, that is x square plus x square is equals to 10 square. X square plus x square means what? 2x square is equals to 100. Therefore, x square is equals to 100 upon 2, that is 50. Therefore, x is equals to root of 50, which is 25 into 2, that is 5 root 2. This is the answer. But see this, how the calculations are. A, B, C, D. Measure of angle B is 90 degree. From the triangle ABC, by Pythagoras theorem, AC square is equals to AB square plus BC square. This is the formula. We know the value of AC, that is the diagonal is given. And AB is x square plus x square. 100 is equals to x square plus x square, that is equals to 2x square. Therefore, x square is equals to 100 upon 2, that is 50. Therefore, x square is equals to 50. Therefore, x is equals to root of 50, that is a 2 into root of 2 into 25, that is 5 root 2. Therefore, the side of square is 5 root 2 centimeter. This is the side. Now, the perimeter is equals to 4 into side, that is 4 into 5 root 2, that is a 20 root 2 centimeter. This is the perimeter. The side of square, that is 5 root 2 centimeter, and the perimeter is a 20 root 2 centimeter. Now again see this here. Now the problem number 6 again. Find the side and the perimeter of a square whose diagonal is a 10 centimeter. Let x be the side of the square, angle B is a 90 from the triangle ABC. See this ABCD, this is x and x, AB is x, BC is x. By the Pythagoras theorem, AC square is equals to AB square plus BC square. 100, that is by mistake here is a 100, it is not the 100. Change it. This is the 100. Therefore, 100 is equals to x square plus x square, which is a 2x square. X square is equals to 100 upon 2, that is equals to 50. X square is equals to 50. X is equals to root of 50. 2 into 25, therefore 5 root 2. Therefore, the side of the square is a 5 root 2 centimeter. Therefore, the perimeter of the square is a 4 into side, that is 4 into 5 into root 2, and which is nothing but 20 root 2 centimeter. Therefore, this is the answer. Side of a square is a 5 root 2 centimeter and its perimeter is a 20 root 2 centimeter. Now the next example is example number 7. In figure, angle DEF is equals to 90 degree. FG is perpendicular to ED. If GD is equals to 8, FG is equals to 12, then find EG, FD and EF. And this is we want to find out. See this, the triangle DEF. FG is a perpendicular to ED. GD is 8. GF is a 12. Now to find out EG by using the geometric mean. This is measure of angle is 90 degree. This is the DFE. By mistake, it is a DEF, but the measure of angle, this F is a 90. I want to change here. I will change on my board. Therefore, FG square is equals to DG into EG. 12 square is equals to 8 into EG. That is 144 upon 8 is equals to EG. Therefore, EG is equals to 18. This is the first part. Now, next is second. In triangle FGD, DF square is equals to GD square plus GF square. Therefore, 8 square plus 12 square, that is 64 plus 144, that is 208. This is the DF square. Therefore, DF is equals to 208. That is in root of 16 into 13, that is a 4 root of 13. Next is, therefore, DF is 4 root of 13. Now, third one is EF. That is in triangle GEF, EF square is equals to EG square plus GF square. Therefore, we will substitute the values. This is equals to 18 square plus 12 square, 324 plus 144, that is equals to 468. EF is a root of 468, that is 36 into 13, which is 6 root of 13. EG is equals to 18. FD is equals to 4 root of 13. And EF is equals to 6 root of 13. Now again we will see here in figure, there is, I will change here. This is a F and this is nothing but E. DFE is equals to 90. FG is perpendicular to ED. If GD is equals to 8, FG is equals to 12, and find EG, FD and EF. Now see this in this triangle DEF, F is 90. FG is a perpendicular to DE by the theorem of the geometric mean. FG square is equals to GD into EG. Therefore, 12 square is equals to 8 into EG. Therefore, 144 upon 8, that is equals to EG. Therefore, EG equals to 18. Again, in the triangle FGD, by using the Pythagoras, we can find out the value of FD or DF. DF square is equals to GD square plus GF square, 8 square plus 12 square. That is 64 plus 144. Therefore, DF square is equals to 208. Therefore, DF is equals to in root of 208. That is in root of 16 into 13, 4 root of 13. That is 4 root of 13. This is the DF. Next, we will find out the EF. To find out EF, we will apply here the Pythagoras theorem for the triangle GEF. Therefore, EF square is equals to EG square plus GF square, 18 square plus 12 square, 324 plus 144, which is 468. Therefore, EF is equals to in root of 36 into 13. That is EF is 6 root of 13. And hence, EG is 18, FT is 4 root of 13, and EF is 6 root of 13. These are the sides. Now the next is, find the diagonal of a rectangle whose length is 35 centimeter and breadth is 12 centimeter. This is the rectangle. The length and breadth is given. Therefore, we will consider here the triangle ADC. Therefore, AC square is equals to AD square plus DC square. Therefore, AC square is equals to 12 square plus 35 square, 144 plus 1225. That square is very simple. Therefore, AC square is equals to 1369. That is, AC is equals to 37 centimeter. This is very simple question. Therefore, the diagonal of a rectangle is 37 centimeter. Now, let's see this again here. Find the diagonal of the rectangle whose length is 35 centimeter and breadth is 12 centimeter. This is the rectangle ABCD in triangle ADC. AC square is equals to AD square plus DC square. AC square is equals to 12 square plus 35, 134 plus 1225. Therefore, AC square is equals to 1369. AC is 37. Therefore, the diagonal of rectangle is 37 centimeter. It's a very simple question. Now we'll see the next question. This is question number 9. It's a star question. In figure, M is midpoint of QR. Measure of angle PRQ is equals to 90 degree. And show that PQ square is equals to 4PM square minus 3PR square. Now see this figure. In triangle PRQ, measure of angle is 90 degree. M is a midpoint, and we have to prove this relation. One thing is that we want to find out PQ square. Which sides are there? There is a PM and the PR square. Now see this one by one. In triangle PRQ, angle R is 90 degree. By Pythagoras theorem, PQ square is equals to PR square plus RQ square. This is the first. Next, triangle PRM. Again, that angle is 90 degree. And therefore, by the Pythagoras theorem, that is PM square is equals to PR square plus RN square. As M is the midpoint of RQ, therefore RM is equals to 1 upon 2 RQ. Therefore PM square, that is RM is replaced by 1 upon 2 RQ, and therefore PM square is equals to PR square plus 1 by 4 RQ square. Therefore multiply on the both sides by 4, that is 4 PM square plus 4 is equals to 4 PR square plus RQ square. That is it. Here we can write it like this, that is the 4 PR square. It can be written as 3 PR square plus PR square plus RQ square. But what is the PR square plus RQ square? PR square plus RQ square is nothing but PQ square. Now see this again here. 4PM square is equals to 3PR square plus PQ square. Therefore, from 1, therefore PQ square is equals to 4PM square minus 3PR square. Therefore, PQ square is equals to 4PM square minus 3PR square. And hence it is a proof. See this again here. What we have to do? That is, we first consider the triangle PRQ. Find the value of PQ square is equals to PR square plus RQ square. Next, we consider the another triangle PRN. In this triangle, measure of angle is R is 90. By the Pythagoras theorem, this is a PM square is equals to PR square plus RM square. M is the midpoint of RQ. And now we'll write here is a RM is equals to 1 upon 2 RQ. Therefore, PM square is equals to PR square plus in bracket 1 upon 2 RQ square. Therefore, PM square plus PR square plus 1 upon 2 RQ square, multiply 4 on both sides. Therefore, you will get PM square is equals to PR square 1 by 4 RQ square, multiply on both sides by 4. Therefore, we will get the result, that is 4 PM square is equals to 3 PR square plus PQ square. This is the value which is the PQ square. Therefore, PQ square is equals to 4 PM square minus 3 PR square, and hence the result is proved. Now the next is walls of two buildings on either side of a street are parallel to each other. This is again the start question. A ladder of 5.8 meter long is placed on the street such that its top just reaches the window of a building at the height of 4 meter. On turning the ladder, over to the other side of street, its top touches the window of other building at height of 4.2 meter. Now see this here. Now in this case, this is the first window and the second window. The AC and here is a CE. This is the ladder which is the 5.8. Its length is 5.8 meter. This ladder reaches at the point A where is window, and here is a 4.2. Therefore, we want to find out here the width of this street. Therefore, by using the Pythagoras, first we find out the BC, second we find out the CD, and add these two, then we will get the BD. Therefore, in triangle ABC and the CDE, AC is equals to C, that is equals to ladder, which is 5.8. A is the first window. AB is 4 meter. AC is 5.8 meter. Therefore, triangle ABC. AC square is equals to AB square plus BC square. 5.8 square, 4 square, BC square. Therefore, 5.8 square is a 33.64 minus 16, that is equals to BC square. Therefore, BC square is equals to 17.64. Therefore, BC is equals to 4.2 meter. By mistake, it is a centimeter, but it is a given in the meter. Also, triangle CDE is a midpoint. I will change this afterwards. E is a point where the ladder touches another point E. Therefore, C square is equals to CD square plus D square. Therefore, 5.8 square is equals to CD square plus 4.2 square. Therefore, 33.64 minus 17.64, that is CD square. Therefore, CD square is equals to 16, CD is equals to 4 meter. Therefore, BD is equals to BC plus CD, that is 4.2 plus 4, that is 8.2 meter, and BD is equals to 8.2 meter. And hence, the width of the street is 8.2 meter. Now again, we'll see this here. This is the problem. We want to find out the width of the street. We consider here the two triangles ABC, CDE. The first triangle is ABC. AC square is equals to AB square plus BC square, 5.8 square, 4 square plus BC square. BC square is equals to 33.64 minus 16. Therefore, BC square is equals to 17.64. Therefore, BC is a 4.2. This is not the, it is a meter. Therefore, I will eliminate it. This is meter. Now, next is also CDE. This is triangle. C square is equals to D square plus CD square. 5.8 square is equals to CD square plus 4.2 square. 33.64 minus 17.64, that is CD square. Therefore, CD square is equals to 16. CD is equals to 4. Therefore, CD is 4. And again, BC is 4.2. If we add it, 4.2 plus 4, 8.2 meter. Therefore, BD is 8.2 meter. Therefore, the width of the street is 8.2 meter. And in this way, we have completed the practice set 2.1. I hope that you would have understood all the problems, whatever that I had explained. Now, we will see in the next video. Till then, goodbye.